Alright, in this video we're going to practice solving a system of equations, of two linear equations, by using the substitution method. In the last video we talked about the graphing method. This is the second method, which is the substitution method, and the third method is called the elimination method, which will be the next video. So, in the substitution method, what you're going to look for is to know that you can use substitution is when you have a variable all by itself. So for example, in all of my examples today on this video, I made all of them y equals. So that way I can just, when y is equal to something, or if x is equal to something, you can easily just substitute it. So again, we also have to keep in mind that a solution is where the two graphs intersect, which is a point. And a point has both an x and a y value. So we need to keep that in mind when we do these, that we don't just stop once we find one answer, because again they intersect at a point which is an x and a y value, so we need both. So let's take a peek at our first example. We have y equals the opposite of x plus 3. And our other line is y equals 2x minus 6. So I know that y equals this. This is y. Alright? And this is also y right here. So what I can do is, since y equals this, I can just go ahead and substitute the opposite of x plus 3 in for this y down here. So I'm going to drop this into this place right here. You'll see what I mean in a minute. So I'm going to say the opposite of x plus 3 equals 2x minus 6. Now if you've noticed, what we did is we eliminated one of the variables. Now I only have x's to solve for. So keep in mind this is a sneaky -1 right here. The next thing I do is I look for the smallest coefficient in front of the x. So this coefficient is a -1, this coefficient is a 2. So I'd like to get rid of the -1. Now again, you can get rid of actually all four of these, any of those four first, but I'm going to get rid of the smallest coefficient first. So to get rid of minus 1x, I add 1x, and I'm going to add 1x over here. This is 0, so I have 3 equals 2x plus 1x is 3x, and I have minus 6. Now it's a two-step equation. I want to get rid of adding and subtracting first. I get rid of minus 6 by adding 6. So over here, this is 0, I'm only left with 3x. And on this side, 3 plus 6 equals 9. To solve for x, I just divide both sides by 3, and x equals 3. 9 divided by 3 is 3. Now keep in mind that my solution has an x and a y. So my x here is 3, but I need to solve for what y is. So, what I can do is I can substitute my 3 into either of the equations. Now I don't like negatives, so I'm going to substitute 3 into my bottom equation. So I'll say y equals 2x minus 6. I'm going to solve for y by substituting 3, which is my x, in for the x, so 2 times 3 minus 6. Y equals 2 times 3 is 6 minus 6, and y equals 0. So my solution is 3, 0. Looking at my next example, I have y equals x plus 1, and y equals the opposite of x plus 3. Again, if y equals x plus 1, and this is y right here, all I'm going to do is substitute this x plus 1 in for this y down here. So I'm going to say x plus 1 here equals the opposite of x plus 3. So x plus 1 equals the opposite of x plus 3. Now again, I'm looking for the smallest coefficient. This coefficient is a 1, and this coefficient is a -1. -1 is smaller than 1, so I'm going to get rid of the -1. I add 1x to both sides. This leaves me over here with 1x plus 1x is 2x plus 1 equals, this -1x plus 1x is 0, so I'm only left with 3 over there. Now this is a two-step equation. I get rid of adding and subtracting first. I get rid of plus 1 by minus 1. Over here, I'm only left with 2x because the 1 minus 1 cancel. 3 minus 1 is 2. So then I solve this by dividing both sides by 2. and x equals 1. Keep in mind that this is only one part of our solution because we need an x and a y value to make a point. So my x value is 1, I still need to find my y value. And again, I don't like negatives, so I'm going to use the top one this time. So I have y equals x plus 1. This one isn't too bad. I know that my x value is 1. I'm going to substitute 1 back in here. So y equals 1 plus 1. We know that y equals 2. So my solution here is 1, 2. That's going to be the point where those two graphs cross. My next equations my next two lines, I have y equals 2x minus 3 and y equals 2x plus 4. So again, y equals 2x minus 3. And again, this is my y, so all I'm going to do is substitute. Since this equals y, I'm just going to substitute 2x minus 3 down here for this y. So I'll say 2x minus 3 in place of this y equals 2x plus 4. So let's write that down. 2x minus 3 equals 2x plus 4. We have something interesting happening here because I have both coefficients of x are 2. So let's get rid of those and see what happens. If I minus 2x from both sides, this cancels out and this cancels out. So what I have left over here is negative 3 on the left side, and on the right side I'm left with 4. So I have negative 3 equals 4. Negative 3 clearly does not equal 4, which means this graph actually has no solution. And if you remember from the last video, the little hint is that both of my slopes are the same. So lines with the same slope are parallel, and parallel lines will never intersect. And if you have lines that are parallel and never intersect, there is no solution because the solution is where they intersect. So this one has no solution. And again, the hint is because both of the slopes are the same. Alright, last one. I have y equals 2x and y equals the opposite of x plus 3. So again, y is 2x, but y is also the opposite of x plus 3. So I am just taking this 2x right here and substituting for this y right here. So I'll take my 2x and put it here, equals the opposite of x plus 3. 2x equals the opposite of x plus 3. Now I'm looking for my smallest coefficient. I have a coefficient of 2 here and a coefficient of negative 1 there. I'm going to move the negative 1x by adding 1x to both sides. 2x plus 1x over here is 3x. Negative 1x plus 1x is 0, and I'm only left with 3 on this side. So to get rid of the 3, I have to divide both sides by 3 to get the x by itself, and 3 divided by 3 is 1. Keep in mind, that's only one part of my solution. The x value is 1. We still have to find the y value. And this last one, I'm going to prove to you that it doesn't matter which one you choose, you're still going to get the same answer for y. So if you're wondering, does it matter which equation I substitute my x back into, the answer is no, and I'm about to prove it to you. So if I substitute y, 1 into here, and I'm going to, so y equals 2 times 1, which is 2. So my y equals 2. We already know that. Let's substitute it in here and see if we still get 2. You should. Y equals the opposite of x plus 3. Now you have to be really super duper careful here because this is the opposite of x. So when I substitute this back in here, I want the opposite of 1. So I'm going to say y equals the opposite of 1 plus 3. Now, if I do, the opposite of 1 is negative 1. So negative 1 plus 3 is 2. So like I just said, it doesn't matter which equation you choose to plug in or substitute your x value in, you're still going to get the same answer for your y value. The solution to this graph is 1, 2.